Hey everybody, today we're going to be looking at 2.2. I do need to do one quick problem from 2.1 that I forgot to do on the notes for those of you who have it. So real quick, we're just going to look at a word problem. So on this word problem, we have a dirt bike and it's jumping off a ramp and then it comes back down and where we have a table here that shows us the times, which is great because then we can make some guesses based on those times what this looks like. So just a quick graph. I don't need to take the time on this one because it doesn't ask me to graph it. But what the graph's going to do for me here is just kind of show me what's going on. And it's going to make it a little easier to visualize some of these things for those visual learners. So keeping in mind, we're starting at 8 feet. So we're not starting on the ground. Okay, so again, heights aren't super important here. I'm not going to make this a super accurate graph. I'm just making a sketch so we can see what's going on. So start not at 0, so somewhere up here, and then we go up, and then because of gravity, we come back down. Okay, and again, we don't need to be super accurate here. We're just doing a quick sketch so we can visualize. Okay, so first off, any kind of function where you have something that goes up and comes back down is always going to be a quadratic, and that's our first question here. Always, unless it hits escape velocity and flies out into space, it's always going to come back down. So it's always going to be a quadratic. Excuse me. And then it asks us to estimate the height at 1.75 seconds. Well, I know it at 1.5, which is nice. I know it at 2, which is nice. I don't know what it is at 1.75. I know it's somewhere in the middle. Okay, and if this were a linear function, it'd be really easy to find that actually. The problem is because it's quadratic, we can't do it quite as easily. Look at this. Okay, so let's start at the vertex. So around 1 second. So if I start at the vertex and I go over, let's say just about a second. Let's say that's 1 second. Or sorry, half a second. Okay, and then I do another half a second. Right? These are about the same distance, but the amount I go down is a huge difference. So cutting this in half, right, because we wanted 1.75, what we're going to notice is the distance from here to here and the distance from here to here is not the same. I've gone much further down here than I did here. Okay, so what we notice from this then is the 1.75, even though it's time-wise in the middle, the up and down distance, we're probably closer to that 1.5 seconds. Okay, so we're probably closer to 20. Now, dead center here would be 14. So probably close to 15 or 15.5. Okay, and again, it says estimate, so we don't need an exact answer here. We're probably close to 15 feet. Okay, on to actual 2.2 today. 2.2 is a really quick lesson. I took a little bit extra time on 2.1 when I taught you guys. I taught you guys the general formula. There's a lot of things in here where they start talking about the general formula. I went ahead and did that in 2.1 because I think it's important that you know what that looks like. So there's going to be some slides where I go rather quickly on. That's okay. You have a lot of these slides too available to you online on Big Ideas Math. Okay, if you go to the student book, so you click the hamburger up in the top corner and then you can click on student book. I'll make a video later to show you how to do that. So looking here, again, we're not going to do all these problems because this is just the warm up. So I've got a 0.52. 1, 2, 3, 4, 5. 1, 2. It's right about here. Okay, and it reflects over the x-axis. So it's going to come from here and then it's going to come all the way down here. Okay, now when we reflect over x, what happens is the x is going to stay the same. Remember, this is 5, 2. What's going to happen is we're going to change the y, and we're going to do what we call an additive inverse. So if it's positive, we're going to make it negative. If it's negative, we're going to make it positive. So instead of going up 2, we're going to come down 2, and now we're at 5, negative 2. Okay. For a y-axis, we would change the x value because we're going from one side to the other, or vice versa. So we're just going to change that x value. We're going to change it from a positive to a negative or a negative to a positive. Okay, next part just talks quickly about line of symmetry. You guys should all be able to do this. Where can I fold this? And it will be the same on both sides. So I fold T down the middle, be the same on both sides. E is this way. L doesn't technically have one. There's one that's almost there there, but if you notice this side's a little bit shorter than this side. Okay, so this one doesn't have one, it's close. And if it kept going, it would. W's down the middle. H actually has two, and then R doesn't have one. Okay. Bonus tip, 0 has an infinite number. I can cut it in any direction as long as I go through the center, and I can do that in an infinite number of ways. Okay, so again, what we looked at last time, we looked at those parent functions, converting them to new functions, and today we're going to kind of be going from instead of not necessarily from a parent function, but from a function to a new function. Okay, and we can do that by modifying the same things. We still have k, it's on the outside. We still have h, it's on the inside. We still have a, which is out front. Okay, so what happens is, remember, these k's move up and down. H's move left and right, but they do the opposite of what makes sense. And then that negative, or the a, remember a can stretch vertically or shrink vertically, and then it can also flip over x. Okay, so again, this is kind of that quick part that we already talked about really last time. So I'm going to go through these next couple really quick. Feel free to pause and go back if you need to. So again, remember k just moves it up or down. Okay, and it does what we think it should. If it's positive, it's going up. If it's negative, it's going down. Okay, h, remember, is opposite because it's inside with x. So that -2 actually went right. Again, we want to think of -2 usually as left, but because it's inside with x, it does the opposite of what makes sense, because it's an input value instead of an output value. And then positive is going left. That negative, again, is just flipping it down. Okay, and then again, this just shows the same thing. And the reason is, again, because of those inputs and outputs. Inputs do the opposite of what makes sense because it's inside the function. Outputs are outside the original function, and they do what makes sense. So let's look at at least one of these, probably both of them real quick. So I'm going to start off with 2x plus 1. Okay, now remember, if I do not have, sorry, I meant to make that blue, keep it consistent with the book. If I do not have parentheses, I want to put them right around the x. Okay, even if there's a squared there, put it right next to the x, as close as possible. It's going to make your life easier. Okay, so looking at this equation, I have an a, and I have a k. Okay, and I'm going to translate those 3 units down. Okay, well, down, remember, is k, and since it's outside, it's going to do what makes sense. So I'm going to modify this for g of x. I'm going to get 2x plus 1, and then that down 3, I'm just going to put on the outside, -3. Okay, clean this up a little bit. So 2x minus 2. And then at this point, I don't really need those parentheses, so I'm just going to distribute that 2. So 2x minus 2. Okay, next one. Same thing, I'm going to use the same original function, except now I need to go left on the graph. Well, remember, left is h. So I'm going to still have x. The problem is I don't have an h in here. But I can add 0 to any number and not change it. So that's important. I can add 0 to any number and not change it. So I can do this. X plus 0. This is still x. So it's the same thing. I haven't changed anything because I'm adding 0 to it. Now we have an h. Now we can do this. Now again, remember, since it's on the inside, left is going to do the opposite of what makes sense. Sorry. Why is it not working? There it goes. Of course, my pen again. Give me 1 second. There we go. Okay. So it's going to do the opposite of what makes sense. So since we're going left, we're going to add 2. So 2x plus 0 plus 2 plus 1. Okay, combine like terms. So 2x plus 2 plus 1. Okay, now ACT tip here real quick. So what you may see on the ACT, you do this problem, we've done it correctly, don't worry. But you do this problem and you don't see your answer. These are the answers you see. You see 2x minus 3, 2x plus 3, 2x minus 5, 2x plus 5. Okay, what you need to do at this step is go, okay, well, I have this function, but it's not in the right form. Okay, there's a good chance if you're feeling confident about your answer that you probably did it right. So let's finish the problem. Okay, and again, this isn't wrong. It's just not finished as far as we want. So I'm going to distribute that too. So 2x plus 4 plus 1, and then 2x plus 5. So there is my answer. Okay, next one. Now I need to be careful on this, because if we read this problem, it says to translate it down and then reflect. Now, I told you in the last unit, when we are doing an order, we always want to make sure we're doing it in the right order, because I showed you on that last problem that if we don't do it in the right order, it's not going to work nicely for us. This problem is asking you to do it in a wrong order. And the reason they're doing that is because sometimes it is important to be able to flip data from a graph that's already made. Okay, so we're going to follow their order. And then we're going to kind of reverse engineer what we should have done to make it work nicer. Okay, so starting out, let's just start with a graph. And I'm starting with an absolute value. Okay, it tells me to go down 6 first. So 1, 2, 3, 4, 5, 6. So now I'm down here. And then it tells me to flip. Okay, now again, flip over x. Now again, because it's telling me to reflect over x, this bottom part is going to come up to the top part, and then these like wing things are going to come down. So my vertex is going to move up to positive 6, 4, 5, 6, and then come down. Okay, so now the question is, how do we get there properly? Because if we can get there properly, then we can create the equation. Because we can't create the equation as easily doing it this way. So again, it's nicer to just kind of graph this one out. Even though it doesn't ask us to graph it, this is going to help us visualize it better. So first thing we're supposed to do is we're supposed to do any stretches or shrinks on A. I don't have any stretches or shrinks. That's good. And then we're supposed to do any flips on A. Now remember, A flips over X. So let's do that first, because I need it facing down. Okay. So next letter is B. B is a horizontal stretch or shrink. I don't have any there. I don't have any flips over Y. It wouldn't do anything anyway, because it would just be turned around. But I do need to move this. So move it left or right. We don't need to do that here. It's all centered. I do need to move it up. So I'm going to move it up by 6. So really, the correct order here would have been to flip over X and then shift up by 6. Okay, putting that back into our original equation. Now we've got g of x. The flip over x is basically a -1 x. I'm not shifting left or right, so I don't have an h. And then I'm moving up 6. I don't really need this -1 because 1 times anything is just that thing. So a negative absolute value of x plus 6. So this is my rule. Okay. Again, there are ways of doing it where you can create the equation from just following the steps, but I find it best for students to visualize it by graphing it out. So I would highly recommend, if you come to a problem on this, like this, and you will on a couple of big ideas assignments, that you flip or you follow the order and then figure out how they did it or should have done it. Okay. Remember, if you have any questions, feel free to email me or contact me through Canvas. I am available during those RTF Fridays. And if you're some of my online students, then I'm available during second period. Have a great day.